Welcome to Brain Vision.
Okay, so let's look at the rates of effusion, or the ratio of those rates for two isotopes. Let's look at uranium-235 and uranium-238. So what we want to know is the relative rates of effusion, or the ratio of the rate, but we're going to look at 238 versus 235. Now, the molar masses of these are relatively close to one another. You only differ by 3 mass units. So we know that the rates of effusion should be roughly equal to one another. Now, how do we figure out rates of effusion? We look at Graham's law of effusion. And Graham's law is that the relative rates of effusion are equal to the square root of the inverse of the molar masses. So if you notice we have a 1 in the numerator for the rates, where the 1 is going to be in the denominator. That's why it's inverse. Now, the 1 and the 2 are the two different isotopes. So here, our 1 is uranium-238, and our 2 is uranium-235. So we're given the molar masses, so let's find the ratio of the rates. So the molar mass of uranium-235 is 235.054. And for uranium-238, it's 238.051. So if we take the ratio is equal to this square root, and we do the math on the square root, we can answer this to 6 significant figures. So we can have a really large number of decimal places here. So to 6 significant figures, it's 0.99365. So this is the ratio, and you can see what this means is that the uranium-238 effuses as a rate of about 99% that of uranium-235. They're pretty close to one another.